Hi everyone, so today is day 22 of September LeetCoding challenge, and this is the problem we will be solving today. So in this problem, like, we have been given an array of strings, and we call this array ARR, and now we want to make a string as with the with the concatenation of the subsequence of ARR. So basically we will be choosing some strings out of this ARR, and then we will try to concatenate these strings to make a string s, and this string s thus formed after concatenating these small strings should contain unique characters. So it shouldn't contain like two a's or three a's or two b's or three b's. So this is the condition. So considering this condition, we need to return the maximum possible length of s. So we can see that the in the first example, the ARR contains the strings un, iq, ue. So all the possible concatenations by following this condition that the concatenation should have unique characters are like the empty string, by just considering this un, by just considering this iq, or by just considering this ue. Or we can also we can also choose these two strings and concatenate them. So un iq is also one possible case, and iq ue is also a possible case. So the reason we are not choosing this and this, because there are two u's. So there is one u in this string and one u in this string. So that's the reason why this is not allowed. And the reason we can't choose all three, because again, like, there will be two u's. So that's why the answer is 4. Similarly, for this case, the answer is 6. So the optimal answer is when you are choosing this or this, or you can also choose this and this. So we get 6 by doing these things, like by making this string as these two strings as, and by considering any other case we won't get any number greater than 6. And the reason we can't choose all three, because obviously if we obviously we can't choose all 4, because there will be multiple a's, and there will be also multiple r's. So that's why these are the answer with maximum characters. And in this case, like, there is only one string, and this string contain unique characters, so this can be chosen. So the length of it is 26. So that's why the answer for it is 26. So now we can take a look to the constraints. So we can see that the length of the array ARR is 16, less than equal to 16. So there will be less than equal to 16 strings, and every length of every string is at most 26 characters. So, like, seeing the constraints, we can see that we can like into use something called bitmask for considering the characters present in this string. So for solving this problem, I will be considering a state dp mask comma index. So this dp mask comma index. So basically, this mask will be this mask will be a integer number of 26-bit. So this mask will represent what are the characters that have been taken in the string as formed till now. So provided that the a is taken, b is taken, c is taken, etc. by this mask. So obviously in this mask, like, the 0th bit is symbolizing whether a is present or not. So if 0th bit is set, then it means that a has been taken, and if the bit at position 1 is set, then it means that b is taken. Similarly, 2 will symbolize c, and similarly 25th bit position will symbolize z. So this is what will be conveyed by this bit mask, and this index will basically represent what will be the maximum possible length of a string that can be formed if the characters that has been taken symbolized by this mask, like basically this state will represent if we are considering all the characters starting from index to the end of the array ARR, and provided that these many characters have been already taken, then what is the maximum possible length of string s we can form. So this is what it will be conveyed by this string, this TP, this state. So like one thing is that we have two choices for the current character, so current string. So the if we plan, like we can choose not to include the string present at the index, or we can also choose to include the string at present at the index. So if we are if uh, if the characters present in the present word are not present in the bit mask, then obviously we can include the present string. So we will first check whether the characters that are present inside the current string are already in the visited, or like already inside the mask or not. So if they are not present, then we will form a new mask, and then we will calculate, we will add the size of the present string and the quantity of new mask comma index plus 1. So this will be the longest string formed if we are including it. So it will be new mask comma index plus 1. Sorry for the bad handwriting. And the when we are skipping the present string, then the value will be mask comma index plus 1. So basically this dp comma, let me erase it. So basically this dp mask comma index, mask comma index will be equal to maximum of dp comma dp mask comma index plus 1 and maximum of this quantity and dp of new mask comma index plus 1. So this quantity will be maximum of these two when inclusion of the present string is possible, and if inclusion of present string is not possible, then this quantity will be directly equal to this quantity. And the base the termination case of the termination condition for the this recursive relation will be that if index will be equal to n, then we can return 0. So this is how we'll be solving problem. So the mask there there will be 2 to the power 26 combination of mask, and this index can range from 0 to 16, right? So these will be the number of what number of states possible, but actually this the number of masks will be less than 2 to the power 26. The reason will be because there are at most only 16 characters, so 16 strings. So these 16 strings, the combination of these 16 strings can't produce a mask of these many masks. So the running time or effective time complexity will be less than this. So yeah, so obviously if there are 16 strings, and like so if we are so how many in how many ways we can select these 16 strings? So we can select them in 2 to the power 16 ways, right? And this 2 to the power 16 ways, each of the 2 to the power 16 ways can generate a unique mask. And that's so basically this the number of total and the time complexity will be 2 to the power 16 into 16. Effective time complexity will be this. Like this is the, like, all the possible combination, all the possible states in the bit mask, but only these many masks will be like used to arrive at the solution. So that's why it is like effectively 2 to the power 20, and this is like around, it is of the order 10 to the power 5 or 10 to the power 6. So this is the reason why it will be like it will give AC. So actually it is 10 to the power 6, because 2 to the power 10 is 1024, and so seeing this 10 to the power 20 should be 1024 squared, so it is of the order 10 to the power 6. So that's why it should give AC. So this solution should pass all the test cases. So we can now try to implement the solution that we just discussed. So first of all, like, we'll be storing the number of strings present in this ARR. So this will be AR dot size, and now we will need a unordered map. So the reason we are using unordered map, because we want to store the computed results. So we'll be doing it by mapping int to int. So we will be basically forming a hash with mask into 20 plus index to for this key, and then we will store the result here. So the reason I am doing 20, because this index can be at most 16. So this will generate a unique key. And now what I need to do, I need to return the DP. So this index will be 0 at first. Now the second parameter will be mask. So initially none of the characters are taken, so it should be 0. Now we'll need n. Now we'll need ARR and lookup. So I guess these are the required parameters. Now we can define the recursive function dp. So the first one will be index. So we are not planning to modify this. So to avoid accidental modification, I'm using const here. So another will be the mask. So it should also be const, and then it should be n. So it will also be const, and then will be the next parameter will be the ARR. So this, it is a vector of a string, so I'll be passing it by reference, and it should also be const. And yeah, so the last one is lookup. So basically we want to modify the lookup inside this function by storing the result of the present subproblem. So we won't be doing const here, but yeah, we will be passing it by reference. So now we have defined this function. So first of all, we need to handle the corner case, like base case. So if index is equal to n, then we can return 0, because we cannot form any more string if we have arrived to the end. Next, we need to do what? We need to do, like, construct the key of the, we need to make the key for the particular state. So it will be masked into 20 plus index. And we will first check whether the subproblem has been computed or not. So if lookup dot find key is equal to lookup dot end, that means that the subproblem has not been solved yet. So in that case, we will be solving it and storing the result. In the end, we want to return the lookup key. So first of all, we'll be checking whether it is possible to include the current string or not. So first of all, I will make a new mask, and I will initialize it with mask. I will make a variable pool possible. So this will basically indicate whether the inclusion of the present string is possible or not. So just in case I will find that there are duplicate characters, I will break the loop and mark this possible as false. So first I will mark the possible as false, and then I will break the loop, because obviously, like, if we'll break first, then obviously the possible equal to false statement won't be ever executed, so that will like be ineffective. So I will be considering all the characters present in the present string. So the present string is basically AR index, right? So first we need to check whether the present string is already taken or not. So if new mask and C minus A, right? So if the present if it will come it will be true, then the present character has been already been taken. So we will mark possible equals to false, and then we will break. And if it is not, then we can set the this bit, right? So now we are done. So if it is possible, so first of all we will initialize this answer with dp index plus 1, then mask, then n, then arr, then lookup. And if it is possible to include the string, then we can update this answer with max of answer comma size of the current string. So current string is AR index dot size. So actually this dot size gives us a long integer for so like long data type. So we need to typecast it into integer, and then we can add index plus 1 new mask, and then n arr and lookup. So this will be the answer. So first we need to store it. So lookup dot key is equal to answer, and in the end we need to return it. So I guess this should work. So let us try to write down the sample test cases to check for the compilation errors. Yeah, so it is working. We can submit it. Yeah, it got accepted. So thank you guys. See you again on day 23. Until then, keep leet coding.